All right, pre-cal students, this is the beginning of Unit 10, and in this unit we're doing identities. And this first lesson is like super important. This is like unit circle important, okay? The basic eight trig identities, these 8 identities that we're going to talk about today, some of them you already know, but these come up throughout this unit and on into the next unit. We'll be using these trig identities, okay? So you need to get these down. You need to memorize these 8 identities. Not that hard to do. So let's define what an identity is first. An identity is an equation that is true for all values for which the variables are defined. For example, a squared minus b squared equals a plus b times a minus b is an identity because it is true for all real numbers a and b. Plug in any real number a or b and this will be a true statement, okay? There are a number of identities that connect the trig functions. These identities provide options for substituting one function for another in an expression. And this is what we'll do. We'll just be substituting, based on the identities, we'll use a lot of substitution throughout this stuff. If P is a point on the unit circle, since it's a unit circle, the radius equals 1, find the value of the 6 trig functions. And so this point P is at xy. So remember that normally we say that sine is y over r. Well, r is 1, so y over 1, right, is going to be equal to y. Okay? Cosine is x over r is 1, x over 1 is equal to x. Tangent is y over x. All right? Cosecant, reciprocal of sine, and so the reciprocal of y is 1 over y. Secant, the reciprocal of cosine, 1 over x. Cotangent, reciprocal of tangent, that's going to be x over y. And the equation of this circle is x squared plus y squared equals 1. You learned that in geometry. I don't know if you remember it, but that is the equation of a circle from geometry when the center is 0, 0. Okay. Oops, you couldn't even see that. There you go. X squared plus y squared equals 1. Now, so this gives us our first 5 identities here. The reciprocal identities. The reciprocal identities, cosecant theta equals 1 over sine theta. Cosecant and sine are reciprocals of each other. Secant theta is equal to 1 over cosine theta. Cosine and secant are reciprocals of each other. Cotangent theta equals 1 over tan theta. Cotangent and tangent are reciprocals of each other. All right? The ratio identities. Notice we said tangent equals y over x. Well, y is sine and x is cosine. So that gives us that tangent theta equals sine over cosine. Okay? Tangent's y over x. Y is sine, x is cosine. So tangent equals sine over cosine. Likewise, cotangent theta will be x over y. So that's cosine over sine. I always remembered this by when cotangent, cosine's on top, when tangent, sine's on top. Okay? Cotangent goes with cosine here. All right. So there's 5 of our basic 8 right there. 5 of the basic 8. So, note on the next page, these single term identities can be squared to form new identities. So if we do tangents, if we square both sides here, square this, I get that tangent squared theta, remember we put the square after the thing before the theta here, is equal to sine squared theta over cosine squared theta. Likewise, cosecant theta, if I square both sides here, I get cosecant squared theta is equal to 1 squared, which is 1, over sine squared theta. All right? Okay, so Pythagorean identities now. Okay? We said just a minute ago that the equation of the circle is x squared plus y squared equals 1. Well, we know that x is cosine, so we could write this as cosine squared theta. Y is sine plus sine squared theta equals 1. Normally we're going to turn this around a little bit and think of it as sine squared plus cosine squared is equal to 1. Really, either way is fine, but usually you see it with the sine squared first. Okay? So that's our first of the Pythagorean identities. All right. So let's say I take this one right here to the left. Cosine squared plus sine squared equals 1. And I divide both sides by cosine squared. Okay? So I'm going to have, let me write it down below. Cosine squared plus sine squared equals 1. And I'm going to divide everything by cosine squared. Okay? Cosine squared divided by cosine squared is equal to 1. Plus sine squared over cosine squared, we just said that that's equal to tan squared, plus tan squared. And 1 over cosine squared. Cosine, remember the reciprocal of cosine is secant, so this is going to be secant squared. So there's our second of the Pythagorean identities, 1 plus tan squared equals secant squared. Okay? Third, I'm going to go back to this first equation, but the right side now. Sine squared plus cosine squared equals 1. And you're probably guessing what I'm going to do here, but yes, I'm going to divide everything this time. I'm going to divide both sides by sine squared. Everything gets divided by sine squared. All right, so what do I have? Sine squared over sine squared, that's 1. Cosine squared over sine squared, that is cotangent squared. 1 over sine squared, we just said a minute ago, is cosecant squared. So 1 plus cotangent squared equals cosecant squared. And that's going to be our third of the Pythagorean identities. All right, now one more note here, bottom of the page. These identities can be solved for any term to form new identities. So for example, if I start with sine squared plus cosine squared equals 1, I could subtract cosine squared from both sides, minus cosine squared, and I would get sine squared theta equals 1 minus cosine squared theta. Or likewise, I could subtract the sine squared instead, and that would have given me cosine squared theta equals 1 minus sine squared theta. So these are just variations of sine squared plus cosine squared equals 1. Okay? Different variations of that. Same thing here. I could subtract the tangent squared, and I could say 1 is equal to secant squared minus tan squared. Or I could subtract the 1 and say tan squared equals secant squared theta minus 1. So there's 2 more there. All right? Again, just variations of our Pythagorean theorem number 2 here, Pythagorean identity number 2. And finally, 1 plus cotangent squared equals cosecant squared. If I subtract cotangent squared from both sides, I get 1 equals cosecant squared minus cotangent squared. Or if I subtract the 1, I would have had cotangent squared equals cosecant squared minus 1. Okay? Hope you're all keeping up here. So on the next page we have kind of a summary of our basic 8 trig identities. Basic 8 trig identities. And I'll give you a quiz on this at some point, and I'm sure it'll be next week sometime. All right? Cosecant, remember, is the reciprocal of sine. So this is 1 over sine theta. Secant, reciprocal of cosine, 1 over cosine theta. Cotangent, reciprocal of tangent, 1 over tangent theta. All right, those are our reciprocal identities. The ratio identities, tangent is sine over cosine. Cotangent is cosine over sine. And finally, the Pythagorean identities, sine squared plus cosine squared equals 1. 1 plus sine squared is equal to secant squared. 1 plus cosine squared equals cosecant squared. Okay? Oh, I messed that up, didn't I? This should be, I'm sorry, this should be tangent squared. 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared equals cosecant squared. My bad. Okay? Had a little brain fart there. All right. You need to get these 8 down. Obviously, I need to get these 8 down too. It's been a while. I'm a little rusty. Okay? You need to get these 8 down. Know them cold. All right? So here's how we're going to use them. And this is pretty simple here. We'll get more complicated as we go along. Use the basic 8 trig identities to simplify each of the following to a single trig function or number. All right? So we're doing just a little simplifying today. With the next lesson, we will actually put them into doing proofs and stuff. So I have sine times cotangent. I know that cotangent equals cosine over sine, so I could say sine theta times, replacing cotangent with cosine theta over sine theta. We can think of this sine theta over 1, and my sine thetas are just going to cancel out. And I end up with cosine theta over 1, or just cosine theta. So sine times cotangent equals cosine. Sine squared over cosine times cosecant. Well, I know that cosecant is equal to 1 over sine. So we could write it like this. Now, this sine can cancel out one of the sines up here. That leaves me sine over cosine. And we know that sine over cosine is tangent. So we got it down to a single trig function or a number here. Both of these we got down to a single trig function. Okay? Cosecant squared times 1 minus cosine squared. All right. So 1 minus cosine squared, anytime I see 1 involved, especially with one of these things, and things are squared, anytime things are squared, my first reaction is maybe it's going to be related to the Pythagorean identity. And I know that 1 minus cosine squared, if I flip back here, 1 minus cosine squared equals sine squared. So what I have now is cosecant squared x. This is equal to sine squared, so I'm just going to replace it. That's sine squared x. Well, now I know this cosecant squared is 1 over sine squared times, I can think of this sine squared as sine squared over 1. I cancel out and I'm left with 1 over 1, just the number 1. Everything else canceled out, it's equal to 1. Okay? Sine x times cosecant x minus sine x. Okay? I know that cosecant x is 1 over sine. So I'm going to have sine x times 1 over sine x minus sine x. I'm going to distribute here. I'm going to multiply sine x times both parts. So I have sine x times 1 over sine x. We can think of this sine x over 1 minus sine x times sine x. So sine x is canceled here. That's 1 minus sine times sine is sine squared x. And 1 minus sine squared, again, going back to the Pythagorean identities, 1 minus sine squared, way down here, 1 minus sine squared equals cosine squared. So 1 minus sine squared x, cosine squared x. All right, cotangent squared. Cotangent squared over 1 plus cosecant plus sine times cosecant. So cotangent squared. From my Pythagorean identities, cotangent squared is cosecant squared minus 1. So I'm going to replace this on top with cosecant squared theta minus 1 over 1 plus cosecant theta. And now I'll replace the cosecant here with 1 over sine. So I know those are going to cancel out there. And I'm going to have plus 1 here. All right. The part on the left, though, this fits the form of a squared minus b squared. A squared minus cosecant squared minus 1 squared, right? 1 squared is 1. So I can factor the top of this to cosecant theta plus 1 times cosecant theta minus 1, all over 1 plus cosecant theta. All right, so now cosecant theta plus 1, 1 plus cosecant theta, same thing, right? If you're adding, the order's not important. 1 plus cosecant, cosecant theta plus 1, same thing. That leaves me cosecant theta minus 1 over 1. So that's just cosecant theta minus 1. And then I still have this plus 1 out here. My minus 1 plus 1 cancel. And I'm left with a single function here, cosecant theta. Last one. Sine theta minus 1 times sine theta plus 1. Okay? If I FOIL this out, this is a minus b times a plus b, I know my answer is going to be a squared minus b squared. Right? This is a minus b times a plus b. So I know it'll be a squared minus b squared. Sine squared theta minus 1 squared, which is 1. Well, this is not quite 1 minus sine squared. Okay? I know 1 minus sine squared is cosine squared. But I can replace sine squared. Let's replace sine squared with 1 minus cosine squared. Okay? I'm going to replace just sine squared. I'm still having the minus 1 here. My minus 1 is still going to be here. But I'm going to replace sine squared with 1 minus cosine squared theta. And now I've got a positive 1 and a minus 1 that cancel, and my answer is negative cosine squared theta. Notice this is the opposite. This is basically, another way you could have done this is to kind of factor out a negative 1 and said this is 1 minus sine squared theta. Negative 1 times 1 gives me this minus 1. Negative 1 times a negative sine squared becomes a positive sine squared. And then this part inside the parentheses is cosine squared. Negative 1 times cosine squared is negative cosine squared. All right, so either way, we get negative cosine squared. Okay, so 2 different ways to do that one. All right, that is it. Practice, get these things down. We're going to be using them a lot. If you do the homework, within a couple days you'll have it down because you'll be using them enough that you will remember these. Don't just copy somebody's homework here. All right, hope you're doing well. I will be back in class tomorrow. For those at home, if you have any questions, let me know. Bye-bye.